Morning, ladies. Good morning. You might be watching this in the afternoon. Hello, ladies. Today we're going to go through the theory and the initial questions in 6B, which focus on index laws 1 and 2. Now, you never have to remember, no one's going to ever say, oh, what's index law 3? Okay, so there's just a bunch of index laws or rules that we follow. And it's not... you're not going to have to need to know, all right, index law 1 is this, index law 2 is this, index law 3 is this, blah, blah, blah. So let's look at index law 1, first of all. So when the bases are the same, so you can see here we have the base A, and it can be a letter or a number. So when you're multiplying by the same bases, so you can see here our base is A, your powers are added. So we keep the base the same, but we add our powers. Okay, so we're multiplying terms with the same base, add the powers. The second index law is the opposite when we divide. So when we're dividing, we keep the base. So here it is with a division symbol or as a fraction. So when we're dividing, the base stays, but we subtract our powers. So when dividing terms with the same base, we subtract the powers. Okay, so let's have a look at some questions. It's a bit noisy outside, but no wonder, because I'm in a classroom, period 1. I'm in my classroom that I'm in for period 1. Got the heater on, so I'm just wondering if any girls want to come in because it's freezing this morning. Oh, okay. So here we've got 7 squared times 7 to the power of 4. So you don't have to expand that, but if you wanted to, that's 7 times 7. And then we've got 7 to the power of 4, so that's 7 times 7 times 7 times 7. So basically, how many 7s do we have? We've got 1, 2, 3, 4, 5, 6. So it's 7 to the power of 6. But remember, when we use index law 1, that's the same as keeping your base the same and adding your powers. Whoops. There we go. So that's a 4. So 2 plus 4 gives you 6. So we don't have to keep expanding it like that. All right, let's have a look at another one from question 2. Okay, so we'll do a division this time. So let's do E, which is 5 to the power of 4 divided by 5. Now, when you don't have a power written here, it's to the power of 1. So that's something that you need to remember because often I see students forget that. So it's the number 1. So if you wanted to, you can do well, you probably don't want to, but I'm just showing you now because it's our first division 1. So we've got 5 to the power of 4 divided by 5. And basically we can cancel out. So this 5 here cancels with this 5 and we're left with 5 to the power of 3. And that is the same as if we did 5 to the power of 4 minus 1 gives you 5 to the power of 3. So see how index law 2, all we need to do is subtract our powers. Now, I might do H because that's a negative base. Okay, so we've got H, negative 2 to the power of 5 divided by negative 2 to the power of 3. So we keep our base. Oh, let me just change my colour. Go over that line. Equals negative 2 is our base. If you want, you can put it in brackets just for the time being and then subtract your powers. Okay, so negative 2 to the power of 2. Now, you can write it like that. I like to put it negative numbers in brackets when we're having a power, taking it to a power, because sometimes you put this into the calculator without brackets, it's going to read that negative sign as separate to the 2 and will give you an answer of negative 4. But this is base, which is wrong. But negative 2 squared is basically negative 2 times negative 2, which gives you a positive answer, so positive 4. So if you use brackets on your calculator, you'll get that positive 4, but I have seen, what am I talking about? Calculators in, that will give you this answer if you don't use brackets. Okay, so just a heads up when entering things into your calculator. All right, let's do question 3. Okay, so quite similar to the previous question, but let's do some harder ones. So I'm going to do m. So we've got 3m cubed times 5m squared. Okay, so let me just change my texter on my pen. Okay, so we've got a 3 and a 5, so we do that first. So 3 times 5, and the base m, and then we've got to the power of 3 here, to the power of 2 here, so we just add our powers. So 3 times 5 is 15. My hands are so cold. To the power of 5, that was a bit of a random comment, but I'm sitting here. My hands are freezing. Okay, let's do another one. Let's do O. So we've got 5c to the power of 4, d times 4c3. Remember, if there's no power there, just add the 1 there, just so you don't forget it. Okay. All right, so we'll do our number first, so 5 and 4, so 5 times 4. You can actually go ahead and just write 20. You don't have to write 5 times 4 if you don't want to, but it's good for me when I'm writing the questions to show you where it has come from. All right, then we've got the base c, so 4 and 3, so we add them. And then your d's, we've got a 1 and a 1. So 5 times 4 is 20, c to the power of 7, and then d to the power of 2. Okay, I might just do p, just do another hard one for you. Now, when you write your z's, make sure they don't look like 2's. Okay, just making sure I copied that down correctly. Okay, so we've got 9. So this time let's do it without doing all this working out. So this is what you'll eventually be doing. So you'd go 9 times 2 is 18. So that is the power of 1. That is to the power of 1 as well. Remember, we do them in alphabetical order. So obviously y is first. And then 1 plus 1 is 2. And then z to the power of 2 plus 5 gives you 7. Okay, so if you can do that in your head, that's great. You don't need to always show that sort of working out. Okay, let's go to question 4. So for question 4, we're using index law 2. So let's do some harder ones. Let's do E to begin with. Uh, 4b5. Okay, so when you can simplify, always do so. So don't leave it as 8 over 4, because that's the same as 8 divided by 4. So the first thing you should do, just draw your vinculum or your division, and then deal with your number part and then your pronumerals. So 8 divided by 4 gives you 2. And then we've got B10, B5. So it's going to be B10 minus 5. And this on the bottom cancels out. You can say it's 1, but we don't usually write it as divided by 1. So now we've got 2b5. Now, eventually you'll be doing this sort of working out. You would probably cancel that out, write the 2, and then you'd say, all right, that 5 makes that a minus 5. And then you'd write 2b to the power of 5. So this sort of working out I would usually do, but you can do this sort of working out as well. All right, let's do some more questions. Let's do another one that's written as a fraction. Let's do G. Actually, I should do F. Sorry. 12D 10 over 36D 5. All right, so the 12 over 36, you think of the highest common factor, which is 12. So 12 over 36 actually simplifies to 1/3, okay, because 12 goes into 12 once and 12 goes into 36 3 times. And then for your D, this D5 is going to make that D to the power of 10 minus 5. So your final answer, we've got on the top 1D5 over 3. Now we don't tend to write the coefficient of 1. So I'm just going to rewrite that like that. So you didn't have to write the 1 there, but I didn't want to not put it there and you think, oh, where did that 1 go? So I just showed you that there, but we don't tend to write 1D squared, we just write D squared. All right, let's do one with a division. Oops. My hands are so cold, I can't press the mouse button. Okay, so let's do I. So we're looking at 4I now. 9m3 divided by m squared. Okay, so the 9's not dividing by anything, so we can just leave that 9 there. Then we've got m to the power of 3 minus 2. So 9m, 3 minus 2 is 1. Now we don't usually write it as 9m to the power of 1, we just leave it as 9m. You can, if you like, convert this into a fraction or write it as a fraction, and then you can easily see, and I've got a student coming in right now, I think, oh, someone's at the door. Oh no, it's a cleaner cleaning the handle. Okay, let's do another one from 4. Let's do L. So we've got 6a6 divided by a to the power of 5. So again, you can write it, leave it like that. So we've got 6a, 6 minus 5, which becomes 6a1, which is then just 6a. Or if you wanted to write it as a fraction, you can. Excuse me. Okay, so that becomes 6a. So either way is fine. All right, let's do some questions from number 5. Scroll, scroll, scroll. I don't always want to do the easy ones. Let's do D. X to the power of 4 times x squared divided by x to the power of 5. Oh, excuse me. Okay, so this one here, you can write the base, okay, which is x, and then look at your powers. So we've got 4 plus 2, and then we've got this 5. So we're going to be subtracting 5. So we've got x, 4 plus 2 is 6 minus 5. So that's going to be x to the power of 1. Remember, we don't usually write it like that, so it just becomes x. Now, if you wanted to see how that actually works, we basically have x to the power of 4 is x multiplied by itself 4 times. And then we've got x to the power of 2, so we're multiplying another 2 times, all divided by x to the power of 5. 1, 2, 3, 4, 5. And remember, they can cancel each other out. So they cancel, they cancel, they cancel, they cancel, they cancel. And we're just left with x. So you can see this is expanding it is a long way of doing it. So you can just add and subtract your powers. All right, let's go to 5G. Okay, so we've got d to the power of 5 times d to the power of 3 over d squared. So when I do something like this, I would cancel that with that, and that makes that one 1. So effectively now we've got d5 times d to the power of 1, which just gives you d to the power of 6. But if you wanted to, you could write d5 plus 3 minus 2, which also gives you d to the power of 6. Okay, so either way, you can work with your problem doing it like that. Eventually, you will do it like that because it's just more efficient. But to start with just learning your index laws, you can do it like that. All right, let's do K. Okay, so we've got 24M, 7N, 5, 5M, 3N. I always think students like surds because when you get to these bigger ones, they look complicated, but it's just a matter of doing a lot of cancelling. Okay, so here we've got a fraction multiplied by a fraction. So if you can remember back to when we learnt multiplying fractions back in year 7, you multiply your numerators and you multiply your denominators. So I'm not actually going to do any multiplications at the moment. I'm not going to do 24 times 5, and I'll show you why in a second. And remember there's multiplied signs in between the numbers and the pronumerals. Okay, so even though there's time, I put times in here. Oh, I can't keep hiccuping. Okay, so let's do some cancelling. So let's look at our numbers first. This 5 can cancel with this 5. This 8 can go into 24 3 times. So we can change that to a 3. Then what have we got on the bottom? We've got, actually I might then rewrite that. So we're left with 3, and I'm going to multiply my bases, yeah. So M is going to be 7 plus 2 is 9. N is going to be 7 plus 4, which is 11. And then on the bottom, I've got M. Now remember that's a 1. It's going to be M to the power of 4. N, and that's a 1 there, so N3. So now I can do some cancelling. So that 4 is going to make that a 5. So remember you're subtracting your powers, and that's going to make that one an 8. So now I'm left with 3M to the power of 5, N to the power of 8, and nothing on the bottom. So it's just 3M5, N to the power of 8. Okay, let's quickly finish in 20 minutes, I reckon. So let's do question 6. Okay, so not too different to 5. Let's do G. So we've got 8K, 4M, 5. God, there's a magpie outside. I love the sound of magpies. Okay, M. Oh, my initials. There we go. Is that nice? Nice way to end the video. So just like before, do your multiplications first. So put everything on the, oh, let's just rub that out, sorry. It's supposed to be a 5. Okay, so put everything on the numerator. And remember, you can put the 1s in now if you like. And then what do we have? 5K, put the 1 in, 3, M3, 4K. Okay, so I'm just going to use a different colour to do my cancelling. So this 5 goes into 15 3 times. And this 4 goes into 8 twice. So I'm going to change that to a 2. And I'm going to scroll. Let's fit everything on one page. So on my numerator, I've now got 2 times 3, which is 6. K to the power of 4 plus 1, which is 5. M to the power of 5 plus 1, which is going to be 6. And then on the bottom, I've got K to the power of 2, M to the power of 3. And now we can just cancel out our powers. So that's going to make that a 3, and that's going to make that also a 3. So we're left with 6K cubed M cubed. All right, girls. Stay warm. Bye.